Hello everyone, my name is Changling Liu. I'm from Case Western Reserve University. It's my pleasure to meet you all and introduce to you my research project, ProMal Precise Window Transition Graphs for Android for a synergy of program analysis and machine learning. First of all, let me introduce what is a window transition graph. A window transition graph, also called WTG, is a GUI model of an Android app, and it's capable of facilitate a variety of downstream tests and analysis. It's a directed graph with nodes being the windows of an app. The windows can be activities, dialogues, or menus, and directed edges are possible transitions between the windows. The transitions are caused by events, and events are users' interactions with the GUI widgets, like clicking a button. WTG can be built through program analysis, both static ones and dynamic ones. Static tools can analyze Android's layout file to identify GUI widgets and their callbacks they trigger. And dynamic exploring tools can run the app and explore the GUI of it using a generated sequence of events. As you can see in the pictures below, there are two problems when using this analysis alone. Static analysis suffers from a high false positive rate, so that the edges you produce cannot always be trusted, and dynamic analysis has very low coverage. Our goal is to overcome the drawbacks of the static analysis and dynamic analysis and to build a precise WTG. Our solution is a framework called ProMal, and you can see its architecture here. It's a tribrid analysis that synergistically combines static analysis, dynamic analysis, and machine learning. First, our framework builds a static WTG as a base one, and we use dynamic exploring to verify each of the edges in the static WTG. For the edges that can be verified, they are immediately true. But for the edges that cannot be verified, instead of throw them away directly, we use a machine learning model to predict their existence. ProMal leverages existing static and dynamic tools to collect the static and dynamic WTGs. Those tools are Gator and Paladin. So before the dynamic exploring, we instrument each app so that ProMal can hook the APIs to record screenshots of the current window and retrieve the view tree and record the coordinate of the event. We identify the widget using the coordinates and the boundaries of the widgets in the view tree. So to align the edges in the static WTG and dynamic one, we compare their source window, target window, widget, and event. The link prediction model is used for predicting the unverified edges is depicted here. It's composed of three modules. First there is a widget embedding module that generates vector representations for the widget in the source window. The vectors are generated from the textual and the visual features of the widget. There is a window embedding model that generates vector representations for a target window. And we use a NTM model for the link prediction. We meet a challenge here that this model requires a large number of data as it has a large number of parameters, but we don't have enough labeled data here. All we can use is a large number of dynamic WTGs collected by the dynamic exploring. But if we only train this model on this dataset, it will be biased towards the edges that can be easily discovered by dynamic exploring. So we use a two-phase training here. First, we pre-train the model on a large-scale dynamic WTGs, and we freeze the embedding models and only fine-tune the link predictor on a small number of manually labeled ground truth. We evaluated our framework on a dataset of 40 apps collected from Google Play and F-Droid, and it achieved promising results. The 40 apps are divided into 8 groups, as you can see in the table on the left. If you look at the table on the right, the precision of our model achieves 94% and with a recall of 77% compared to the precision recall using Gator alone. It's significantly higher, as Gator only has a 46% precision and a 60% recall. It's also better than using Paladin alone. As you can see, the Paladin has a recall of only 72%. So this is the research project I'd like to share with you, and I'm happy to take any questions.